Alright, thank you for joining me today. We're going to be talking about how to use nets to find surface area of three-dimensional figures. We're also going to be talking about just simply surface area of three-dimensional figures. So let's discuss what surface area is first of all. Again, surface area can be summed up very easily as the area around a three-dimensional figure. So in other words, when you wrap a box, during Christmas if you're wrapping a box with paper. Any prism surface area can be defined as 2 times the base plus the perimeter of the base times height, and we'll talk a little bit more about that once we get into some examples. Down here at the bottom you have a note that just simply says if you remember how to break up a shape into its net, you can also use a net to help you find the surface area of a figure, because you can go and find all the areas of the shapes that make up that particular figure. We'll see some of those in just a moment. But first of all, what if we get a three-dimensional enclosed figure like this? Well, it's good to know how to find the surface area. So we're going to use the formula we just saw a moment ago, which is 2 capital B plus capital P times capital H. All right? And we'll just kind of define what each of those are really quickly. The capital B means base, but of course when we're talking about the base of a prism, that could be any shape. So for instance, in this case, our base is a rectangle. Alright, so we know because our base is a rectangle, we'll have to use the rectangular base formula there to find the area of that particular part of the prism. So to start off, we're going to say that it's going to be 2 times the length and the width of our base, which is going to be 4 times 3. Right, and again, we know it's length and width because it's a rectangle, and that's the area formula for a rectangle. Then we're going to add, the P represents the perimeter. We're going to add the perimeter times the height of the entire prism. So let's find the perimeter first. The perimeter, when I say perimeter, I'm talking about the perimeter of the base again. So that would be right where my arrow is. We're using 4 and 3 once more. You always want to find the perimeter of the base shape. Not one of the long faces, but in this case the base shape. So that's going to be 4 plus 3. And because it's a rectangle, we know the opposite sides are also 4 and 3. Alright, so we're going to add those up. And when you add those up, you're going to get 4 plus 4 is 8, 3 plus 3 is 6, and 6 plus 8 is 14. So our perimeter becomes 14. And then we're going to multiply 14 times the height. Well, the only number we haven't used at this point is 12. How can we know that 12 is the height? Well, again, the side or the edge, 12 in this case, is representing this long edge right here, okay? The edges are the lengths, are always going to be the height of a prism because those lengths connect your 2 bases. So the lengths that connect your 2 bases are always the height of a prism, even though they may be laying down, okay? Most of the time we will think that it has to be standing up, but in this case that's not true. They can be standing up, but they just aren't always. Alright, so we're going to use 12 as our height. And we're going to have to do some multiplication. So we'll start to the left here. We can do 2 times 4 is 8. And then 8 times 3 is going to give us 24. Alright, off to the side we may have to do a little bit of scratch work here. That's going to be 14 times 12. Alright, and 14 times 12, 2 times 4 is 8. 2 times 1 is 2. Bring down your 0. 1 times 4 is 4, and 1 times 1 is 1. So in adding that all up, we'll end up with 168. So we need to take 168 and add it to 24. And when we do that, 8 plus 4 is 12, carry your 1, 6 plus 2 is 8, plus 1 is 9. We get 192. In this case, it's inches squared, and I know that may seem a little odd because we're dealing with three-dimensional figures and usually we do inches cubed, but again, we're not finding volume here. Volume is how much a shape can hold. Surface area is how much can surround a shape. So that's actually still 2 dimensions, and you'll see why in a moment when we look at the nets. So let's look at one more like that, and we're going to again use the same formula. 2b, 2 times the base plus the perimeter times the height. Alright, so again we need to define what our values are here. So it looks like our base, once again, just based off of what I'm looking at up here, is going to be a rectangle. So I need to use the rectangle area formula for my base. So that's going to be 2 times length and width, which will be 6 and 3. All right, and again, the reason why I know that is because you can see how 9 is connecting my two bases, the top base and the bottom base. So 9 has to be my height of the prism. So we're going to use 2 times 6 times 3, which is 18. All right, 2 times 6 times 3, which is 18. And we're going to add that to the perimeter of our rectangle. And again, rectangles have opposite sides that are equal. So we also know that this side over here would be 3, and this one would be 6, this would be 6, and this would be 3, just like it would be on the bottom. Okay, let me clean that up just a bit there. So we can find the perimeter of our base by just simply adding those up. 6 plus 6 is 12, and 3 plus 3 is 6. So our total there is going to be 18. And then that's what we will take and multiply by our height, which we've already defined, because that's one of the edges that connects our two bases together. So 18 times 9. All right, so we need to just get doing some multiplication here. And that was 18. We added those up. So that's going to be 2 times 18, which is going to give us 36. And then off to the side, we'll do 18 times 9 as well. 8 times 9 is 72. Carry the 7. 8 times 1 is, or excuse me, 9 times 1 is 9, plus 7 is 16. So we get 162. All right. So now all we have left to do is add them. So 162 plus 36. Lots of work here. 6 and 2 is 8. 6 and 3 is 9. And bring down your 1, and you see you get 198, again, inches squared in this case, not cubed. All right, so I mentioned before you can actually break these shapes up into nets. And again, this is just one example of what a net of a rectangular prism would look like. And you can see, again, they still just give you 3 dimensions. You can use this to find your surface area in much the same way. You can see that your bases would be along this side right here, and these would be your faces in the middle. All right, so basically you're looking at a shape here that would result in a rectangular prism. So we're going to take and do some multiplication. This time we're going to use the alternate formula. I didn't use it before, but I do want to point it out to you because there are multiple formulas you can use. And that formula is 1/2, or excuse me, not 1/2. That formula is 2 times length times width plus width times height plus height times length. I ran off the side there just a bit. I'll rewrite that. 2 times length times width plus width times height plus height times length. All right? So basically, and I'll explain what that means, is you're taking all of the dimensions that are a part of the prism that you can see right here, 2, 5, and 10, and you're going to multiply them together. Each and every one of them one time by each other. And then you're going to add up what you get and multiply it by 2. Okay? So let's take those and see what we end up with. So our formula again is 2 times, we're going to take 2, 5, and 10 and multiply them by each other each once. So let's just start with 2 and 5 because it doesn't matter what order. So 2 and 5, 2 times 5, and then we're going to add that to, let's do 5 times 10 as our next one. And then we'll add that to the last one. The only 2 we haven't multiplied together yet would be 2 and 10. So 2 times 10. All right. We do all of that math and then multiply everything by 2. So inside the parentheses you have 2 and 5. So 2 times 5 is 10. Added to 5 times 10, which is 50. Added to 2 times 10, which is 20. So at that point we add those up. 50 plus 20 is 70, and 70 plus 10 is 80. So 2 times 80, which in this case would give us 160 inches squared. So if you find that formula to be a bit easier, you can also use that. And just let me briefly explain why you're doing a couple of these things. First of all, each of these rectangles has a length and a width and a height to it, okay? And the reason why we're doing it twice is you can see there's 2 of these long rectangles that go together, and then there's 2 of the small ones that go together. So you're multiplying it by 2 so that you can actually take into consideration the perimeter, which we did before, or excuse me, the fact that there's 2 of them. So we need to make sure that we multiply by 2 to compensate for that in the math. Alright, let's take a look at the surface area of something other than a rectangular prism, and that would in this case be a triangular prism. We know it's a triangular prism because you can see it has rectangular faces that are connecting 2 triangles on either side. So the triangles would then be our 2 bases. The rectangles on the other that go around the sides of the triangle that connect each of them together would be why we call it a prism. Alright, so the formula you're going to use here is still 2b plus ph. Alright, but this time, because we're not dealing with a rectangle, we're dealing with a triangle, we're going to have to modify that capital B in the formula. This time it's going to have to be the area formula of a triangle. The area formula of a triangle is 1/2 base times height. And you notice that I use a lowercase b this time to represent the base of the triangle, not actually the base of the prism. Okay, so now we're going to start substituting in some values here. The base and height of our triangle would be 5 and 6. Okay, 5 runs along the bottom of our triangle, and 6 is going to represent the height. Alright, 6 being the height in this case means that we need to use that as the lowercase h and not the uppercase h, because the lowercase h is a part of the area of the triangle only. The uppercase h is the height of the entire prism, so that's different. So as we start filling in our values here, it's going to be 2 times 1/2, let's see, that's going to be 1/2, 5, which is our base, times 5, whoops, times height, which is 6. Alright, and then the capital P would be then the perimeter of your triangle. Alright, so we can see that we have a base of 5, and this side over here is there to help us get the perimeter of our triangle in. The 2 sides here, 7, are going to both be congruent, are both going to be 7. So in this case, we're going to find the perimeter, we're going to have to add 5 plus 7 plus 7. This side here would also be 7, and this side would also be 7. Okay, so that's why when we're finding the perimeter, what you find the perimeter of again in these problems is the base of the prism. Alright, so 5 plus 7 plus 7 in this case, so that's going to be 7 and 7 is 14, so 14 plus 5, which would give us 19. So our perimeter is going to be 19, and then we will take that and multiply it by the height of the entire prism. Now again, you have a height of a triangle and you have the height of the entire prism. The height of the triangle is 6, so we're not going to use that. We need the height of the whole thing, the whole prism itself, which is going to be 12. Okay, and again, the reason why we can recognize that as being 12 is because it's always going to be one of the edges, the length of the edge that connects the 2 bases. So that edge would run from here to there. And it's connecting both the triangular bases, so that's the height. So 19 times 12. So at this point, we just have a lot of multiplying to do. So we'll start with that one thing at a time. Let's start with the parentheses here. So 5 times 6 is 30. Alright, so we're going to do 1/2 times 30. Well, multiplying anything by a half is like dividing it by 2. So at that point, we can go ahead and just divide 30 by 2, which is 15. And notice when we do that, we then have to multiply it by 2 again. So you kind of do a full circle there. You end up with 30 all over again. So we end up with 2 times 15, which is 30. And then we're going to add that to 19 times 12, which I'll do off to the left here. 19 times 12. All right. 2 times 9 is 18. Carry the 1. 2 times 1 is 2 plus 1 is 3. Hold the place with 0. 1 times 9 is 9, and 1 times 1 is 1. So we have 8, 3, 9 and 3 is 12. So you end up with 228. So when we add those up, we will end up with our surface area. So that's going to be 8 plus 0 is 8, 2 plus 3 is 5, and finally 2 plus 0 is 2. So we end up with 258 centimeters, again, squared and not cubed. Okay. So again, you can also break the shape up into what we consider to be the net. Okay, the net looks fairly similar to this. You can fold up the two sides onto the triangles, and you ultimately will get your triangular prism. But here we can also break it down in terms of all of these rectangles being the same size, and of course the two triangles being the same size. So what we could actually do is find the area of all these figures, okay, and then add them all together. So that could be pretty easy, because if we find the area of this rectangle, then that means we found the area of this rectangle, which means we found the area of this rectangle. So in this case, we don't really need a formula. We just need to be able to find the area. So I suppose we do need the area formulas. In this case, rectangle and triangle. Okay, so let's go ahead first and start with the rectangles. The area formula for a rectangle is length times width. So that's going to be 4 times 12. 4 times 12. Here's your length of the rectangle. Or I would say that's probably the width, and then your length would be 12. So we know we get 48. So instead of having to add up 3 48s, why don't we just take 48 off to the side and multiply it by 3, because we have 3 rectangles. So 48 times 3 is going to give us 3 times 8 is 24, carry the 2, 12, 13, 14, so 144. So we'll write that off to the side because that's the surface area of the rectangular part of our prism. But of course we also have 2 triangular parts as well that we have to account for. So let's just simply find the area of one of those triangles and then multiply it by 2. The area formula of a triangle is 1/2 base times height. Okay, so we have a height of 3, which we can see right there, and we have a base. Now we can't really tell what the base is, however all of these sides are going to be the same, so we should know then that the base would also be 4, just like the rest of these sides of the rectangles. So we're going to do 1/2 base 4 times height 3. Alright, so that's actually going to be 1/2 times 12. 1/2 times 12 is going to give us 6. It's like dividing 12 by 2. So when we end up with 6, we then can multiply that by 2 again, because remember, we have 2 triangles in this. So when we multiply that by 2, we get the entire surface area of our triangles in the figure as well, and we need to simply just add that and finish off our surface area. So that's 144 plus 12, which is going to give us 156. So 156 inches squared is what it would take to cover this and something in particular. All right. And the last type of figures you'll have to deal with, we actually will call composite figures. We put these in with nets because, as you can see, they actually work as almost floor plans. If you look at the top of your floor plan of your house, so if you're up on your roof looking down into your house, you would notice that all of your rooms are kind of, well, a lot of them are kind of this shaped. They're not perfect rectangles necessarily. They kind of V off and curve off, and they make a bunch of little rectangles if you separate them up enough. And that's exactly what you're going to do here. Notice we can actually take this figure and separate it into 2 rectangles, one way this way or one way that way. Okay, and that would actually then be like the walls of a room if you were looking over your house again. So you need to just simply choose which way you want to do it. You can either connect from here to here, or you can connect from here to here. I can't tell you how, like, which one's better, or it's completely up to you. But at this point, what you're trying to create here is 2 rectangles, because one of the easiest area formulas to use is a rectangle formula. So we're going to create 2 rectangles, find their areas, and then add them together. So let's go ahead and let's just separate this out long ways like so. Alright, so we have a rectangle here and a rectangle here. Now we can pretty easily find the area of this rectangle right here, and I say that because we have this dimension here of 12 feet and this dimension here of 8 feet, which we can basically just go ahead and say 8 times 12 to give us the area, because that's the area formula, length times width. So if we go ahead and do that, we'll do 12 times 8. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. So this area here in blue would be 96. Alright, but you also have this area over here that we need to find still as well. Now this one isn't quite as easy because you'll notice that this entire side right here is 20 feet. Well, we don't need 20 feet. We only need the distance from where we cut it off right here. So we just need this distance right here. And to find that, we're just going to do a little bit of subtraction. Notice our 12 feet dimension right here goes and then stops at that wall, the wall that we made. If we subtract 20 minus 12, it's going to give us the remainder of the distance that we need. So 20 minus 12 is going to give us 8. So we now can find the area of that remaining rectangle by taking 8 and multiplying it by 15. Alright, so 15 times 8 is going to give us 40, carry the 4, 8 times 1 is 8, plus 4 is 12, so 120. Alright, so then to finish off this problem, if we want to find the area of the entire figure, we're going to go ahead and add those two together. And you get 6, 9 plus 2 is 11, carry the 1, and then a 2. And you finish up with 216 feet squared. Alright, this has been a quick tutorial on how to find the area of polygons. Thank you for joining me. No, not area of polygons. What did I do? Oh, that's right. Surface area. Dang it. I read the top again. Alright, sorry. So using that surface area, that's right.
Okay, so
go ahead. Alright. Thank you for joining me. This has been a quick tutorial on how to find the surface area of three-dimensional. I can't think right now. Nets.
Using nets to find surface
area. Alright. Thank you for joining me. This has been a quick tutorial on how to use nets to find surface area.